All right, guys, what's good? What's good? Today we're gonna be solving car fleet. All right, so let's go ahead and read the question. All right, so car fleet. There are n number of cars. So there's n cars traveling to the same direction or same destination in a one-lane highway. Okay. You are given two arrays of integers, position, and speed, both of length n. Okay, so we know we're given two arrays. Okay, say that. Two array given. Same length. Okay, they are the same length. Okay. Position I is the position of the ith car. Okay. Position I is the position of the ith car. See, speed I is the speed of the ith car. Okay. So we're given speed and position. Okay. The destination is at position target miles. Okay. So the end is the end, the finish, let's call it the finish line, is at miles, which is just an integer. A car cannot pass another car ahead of it. It can only catch up to another car and then drive at the same speed as the car ahead of it. Okay. So if there's a slow car in front of you, you're bounded to that speed. You and that car are like one unit. Okay. Mm-hmm. Okay, a car fleet is a non-empty set of cars driving at the same position at the same speed. Okay, so when a fast car reaches a slow car and they're at the same position at the same time, I would say that is considered a car fleet. If a car catches up to a car fleet at the moment the fleet reaches the destination, then the car is considered to be part of the fleet. Return the number of different car fleets that will arrive at the destination. So let's say an example would be car, our target is 10, so we have finish line would be 10. Go run this. Let's go run through a test case. So target is equal to 10. Positions we have, so that means positions is 1 and 4. I think we could put a comment. This means that there are two cars. Okay, next would be speed. So speed would be 3 and 2. Okay, so that means car at position 1 drives at speed 2 or position. So car, this means car 1 drives speed 3. Next would be 2, car 2 drives at speed 2. So we kind of have to calculate, well, 3, I think we have to calculate if car 3 will join with car 2, if car 1 will reach car 2 before it reaches the finish line. Okay, how can we do this? I think we could have a calculation. Let's see. We could do maybe 10 divided by 3. 10 divided by 3, which is outputting to, well, actually, I'd say 10 minus 1. 10 minus 1, because we're at position 1, which equals to 9. And then from there, we get that 9, and we divide it by 3, right, which is equal to 3, which is equal to 3. Then we could say that 3 has, or car, car 1 reaches, the car 1 takes 3 Um, three. I'm just gonna say minutes. I'm gonna say one. Three indexes. No, 3 minutes to reach finish line. Okay, let's go ahead and compute the second one. So we have position four, which is car two. So I would say 10 minus four. I would say that this is equal to six. Now we do six divided by two, and that is also equal to three. And let's say because two, car one and car two, no, because car one is greater than or equal to car one's car one's minutes takes to reach finish line is greater than or equal to car two's version of car two mins takes to reach finish line. We go ahead and say that they are a fleet. We could just conclude they are a fleet. So we combine both of those and we say output is one. Okay. I think we could run through that math question for all of these, and then we could just group them together based on their index. Um, okay, let's try to do this with multiple cars. I think a stack would be nice. We could make this computation. And if let's say if this actually was eight. Hmm, no, six. Okay. Now let's go ahead and put this into an algorithm. Hmm. Mhm. So four. So there's a car at position four, one, zero, and seven. Position four. Hmm. So the car at position four has speed two. Hmm. Okay. So we got to get its speed for each one. What do we do after we have all of these numbers? We can see if they're equal. The position really does matter. How do we organize the position for these? Mm-mm-mm. I think that's the question in my head right now. How can we keep track of, I guess we could have a, hmm, I'm thinking sorting would be good, but if you sort that, if you sort this, we're gonna lose its speed. Let's see if there's any hints out here. Recommend space complexity. Wow. If it uses this amount of time, I'm thinking we gotta sort. I think we just put them all into a stack. Then we sort it from there. Oh yeah, that'd be crazy. Yeah, we could do that. We could make everything into a stack, right? We could have a stack which is equal to something like this, right? And then it would have something like the first number would be four, which means it started in position four. And then next would be its speed. Its speed was two. So we'll have a stack kind of like this, right? And then we'll have another one, kind of like one, and then had speed two, right? Then we could just sort from the first number. We sort from the first number, right? So we sort from 4 and we sort from 1. And then from there, we'll have its starting position. Then it's way easier to calculate. Okay, let's go ahead and do that. After we do that, let's say we come with all of them sorted. Okay, so let's go ahead and sort them all. So that would be stack of, C stack would be, well, let's go ahead and move this over. Okay, I would say that's on the bigger end. Okay. Okay, let's go ahead and add this one. It would be 0 at position. So 0 and it runs 1. And another one would be 1 and it runs to 2. Runs 2 miles per hour. Okay, so we got 0, 1, 4, and now we get 7. 7 would run at 2. Well, 7 runs at 1. So it's a 7, comma 1. And now that it's actually sorted, this is what we want. Then we go ahead and do the math. We run this math right here. Okay, let's go ahead and run the math. See, so, okay, position 1. So 0 and runs at 1, so that knows that that'd be um let's see, target is 10. So we do 10 minus 1 is equal to 9. Then 9 divided by 1 is 9. So this will take 9. Take it 9. Let's do another stack. Okay. So this one would take 9, comma. This would take let's see, 1 and 2. So that'd be 2 is the speed. So it'd be 10 minus 1, which is also 9. Oh, this would actually be 10. So 9, 9 divided by 2. Okay, let's just say 4.5. So this would be 4.5. Okay. And then let's see. 4 minus that's 10 minus 4 is 6. 6 divided by 2. That'd equal 3. And 7. So 7 minus that 3. 3 divided by 1 would equal to 3 as well. So we could see that there would be okay, now that we have this result, let's see how we could get this result and try to get the output of 3. So 3 and 3, these, this will take 4 minutes to go. This will take 3 minutes to go. So I see three fleets right here. Fleet 1 is just 10. So I would say I'm gonna put them in fleets. 10 would be 10. 4 would be 4.5. And the last one would be 3. So one group lands at 3, one group lands at 4.5, and one group lands at 10. The condition, I'll say the condition to make it a to make it a group is if the previous number, we could check if 10 if the number before it, so if it's like 4.5 and this one goes to 10, then we know that this is a fleet. This is a fleet just because we check. So our stack would check. Our stack would check if the number we are trying to add is is, is bigger than our last number on the stack. And if it is, and if stack at this negative position, so let's say this is smaller than the current one, Then the current index, they're in a fleet. So we don't increment it. Therefore, we can pop from the stack and don't mint the answer. Else, if it is smaller, then we know they are separate fleets. Therefore, we can just increment the output by one. Okay, I think that's it. That should be the solution. Now we actually got it coded up. Okay, sorry, I got distracted a little bit. Got a text message. But now that we have this, let's go ahead. Oh shit, there's a lot of paperwork. Let's go ahead and try to solve it now. So let's do this in steps. So first of all, we want to make a stack and sort it. That was the first one. Let's go ahead and make the stack and sort it. So let's go stack is equal to actually we don't even have to make a stack. I'm gonna say sort cars. Sort car is equal to it's gonna be empty for now. I'm gonna say for index in range length of I can take any of this. I'm just gonna say position. Okay, now I'm gonna say sort car. Sort car dot append. We want to just append index. We want to append position index. And for the other one, we want to just do what's it called? Speed dot index. I'm gonna say speed index. Okay, so that's two. Okay, and now that we have that, this is okay, so sort car now has all the elements in it. Let's actually go sort it now. So we have to sort it by its first position. So how do we do that? We do let me think. I think there's a lambda expression. Let's say sort car dot sort by I think it was like a lambda lambda equals I think it's position 0 of sort car. Man, I don't know. In nested list. All right. Mm, yeah. Okay. I almost got it. Key is equal to lambda. Key is equal to lambda, and we go ahead and put this little equal thing. And what do we sort it by? We sort it by x and x of 0. Mm-hmm. Sorted. We don't want sorted. We want sort. Okay. Okay, now I can say that this is sorted. Now it is sorted. Yay. Okay. Now that it's sorted, we want to go ahead and run the second part. We had to comment this stuff out. We comment all this stuff out too. Oops. I think I needed one more quote. Okay, there you go. Okay, and now that we have the sorted thing, we go do it the math now. So let's go ahead and do the math. Let's say 4 for each car in sort car. Okay, we want to do the math. Let's go ahead and get that math. What was the math again? We get target minus um minus the distance. What is the distance? The distance is the current position, so that would be sort car at position 0. Okay, distance left. And now we do distance left. Distance left is divided by, let's do double divide, right? Shouldn't it not matter? I think. Mm, I just do single divide. Distance car divided by, wait. Mm, okay. Okay. We could chill with that. So the distance left divided by, you could say sort car. And this is going to be the speed. We know a sort car at 1, it would be the speed. This is the speed at 1 is the speed. And okay, now we go ahead and see distance left. And we keep this as, mm, we put this in the stack actually. Let's go ahead and make our stack now. Okay, now we do our if condition. Remember, if the number was bigger, if the first number, see, if the last number on in the stack is bigger than, if the last number in the stack is bigger um than the current one, then index, then we could just then we can increment answer. Do we have answer yet? We never said answer. Okay, let's go ahead and put answer right here. So answer is just equal to 0 because answer is going to be just an integer. Okay. Okay, so now we do if, hmm, Oh shit, my friend trying to play some League of Legends. Let me do that. Let's see. Uh, why is it always? Hmm, okay, let's see if I could share my screen. Could I double share my screen? Let's go entire screen. And I'm gonna go ahead and hit share. Where the fuck? Oh, there you go. Okay. All right. Okay. So, okay. If we can increment the last number is bigger than index, okay, let's go ahead and try to figure this out. If stack append equals distance left score car, I think we could ignore it. We can increment answer. Damn. If the last number on the stack is bigger than the current index, we could increment answer. Okay. Now we just compare. So stack append. Okay, so we check the stack, if there even is anything on the stack, and stack at this last position, let's say -1, is less than, or if stack's greater than, then we know a stack. Okay, let's see. The distance left. Uh, let's go ahead and compute this actually. All right, let's go ahead and put this into a variable instead. I'm gonna say this I'm gonna say target dist is equal to actually this. Okay. Okay, and now let's say if that's less than greater than target distance, then okay, then we could go ahead. Do we even have to append? Let's see. I know that we do increment the answer, so let's go ahead and increment answer. So let's do plus equals 1. Okay. Let's see. Okay, so we could do answer plus equals 1. Now I'm debating should we actually add it. Okay, let's see. If it's a different fleet, we go ahead and remove. We go ahead and pop it actually. I think we could pop the latest element and add our new element in, right? Let's see. Let me think. Let me visualize. Okay, so 10. We could have both of them. Remember, if the number is bigger, ooh, what is this? If it's bigger, hold on. Something is coming up on my phone. Okay, if it's bigger, do we still need to append? If stack and stack -1 is greater. No, we don't even care about the last element. We could go ahead and pop. I would say stack dot pop because that will get rid of the fucking thing that it'll get rid of this right here. And we go ahead and just append our new one. Yeah. Okay, now stack, append. Let's go ahead and append our new car. But we need the car's actual target distance. Okay, and the other condition is if a stack The other condition would be if if it was larger. Okay, if it's less, if stack, if top of stack is less than, if stack is top is less than the current, then we know, then we know that they'll be they're gonna be part of the same fleet. They will be part of the same fleet. I think we could pop regardless, right? Yeah, we pop regardless. Yeah, I think we could go. We pop regardless and we always append. Yeah. Mm, because we're bounded. I think we can pop regardless. I know, so my gut is telling me that's like not the point of a stack. But let's go ahead and try to this. But we don't have to increment answer. Yeah, okay. And with that, I think we can just return answer, and that should work. Let's go see. And we ran into an issue right here. Let's see. Indented block. Go ahead, check it out. I'm gonna go move this a little bit. Okay, let's go look. Okay, definition of the car fleet. I don't see any indentation error. Is it an expected indentation block? If we're on this, I don't see the indentation error, right? Because isn't this right? Is it because of this shit? Hey, it's this. Yeah, it's this, huh? There you go. Yeah, okay, there you go. See what kind of issue we ran into here. So, in support operand for minus int and list. So target minus sort car at 0. So target is an integer, sort car, I guess it's not an integer. So sort car is actually two things. Yeah, we want to subtract it at position 0, and it's supposed to be 2. So okay, sort car holds the position, holds position, and then speed. So we want to subtract target is equal to position. So 0. Oh yeah, this is actually target. Yo, bro, what's good? Sup, bro? I need to finish this question real quick, man. I'm still recording. I'm gonna be talking out loud though, so you might want to mute me up.
It's okay, bro. I don't care.
Okay.
Right now? Please, Justin in this Discord.
I think so. I don't know. Just invite him.
Whose Discord is this?
Discord is who?
Whose Discord is this?
Oh, it's mine, bro. My Discord.
Oh,
Actually, I'm gonna mute your shit up, bro, because I need to finish up this question for the tutorial. All right, fine. Mute yourself now. Yo,
show the tutorial my beat,
bro, hey, bro, let me just finish this so I can listen league, man.
bro.
All right, fine. Guys, what's up? What's up, guys? Today we have a guest entrance. We're gonna check out Aaron's beat. Let's go ahead and watch his stream, see what he got to show.
Hold Load up.
I forgot. I'm not sure if the stream is able to hear like whatever's on my computer. We'll see.
Fuck it. Wait, do you want it? All right, not fuck it.
Okay. Okay. That's pretty fire, bro. You got a little Uzi on that shit. You got a little Uzi? Hell yeah. Fuck yeah, man. That guy's the GOAT.
Yeah, hell yeah. Yeah, you fuck with it.
Fuck yeah, fuck with it, man. That shit was clean. I like
Hell
that.
yeah.
Yeah, that one part at the end, bro. You want to go back to it? It was kind of far. Like Lil Uzi wasn't singing, but it was like you're playing with the music and stuff.
Okay. Yeah, let me go back.
Yeah,
Yeah,
go
you
back.
need
I'll show you, bro. I'll show you the part.
a reaction video. You
Yeah,
know,
okay. It was like 90%, like you're like 90% done with the music or the song.
here.
Yeah, like no, a little bit more to the right. All right, yeah, keep on playing it. Actually, no, a little bit before. Oh yeah, this shit right there. Yeah, that shit heat, bro. Oh yeah, right there, bro. Yeah, that shit heat. I gotta finish up my tutorial now. All right, so right here we see that for for car and sorted car, the error that we're having right now is that we're we're trying to access negative int for int in list. So you see that's kind of trying to subtract a sort car, but sort car is actually a nested list. So what we gotta do actually is get switch car and do it int. We're gonna say for index car for index in range sorted car. range length of sorted car actually. Then we'll have the index, but then we'll do index right here. Mm-hmm. Mm-mm. Oop.
Uh, 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 uh,
Let's go ahead and look this up. Oop.
Dude, what if you're like about to get hired and they see you using like ChatGPT to help you?
Mm. Oh no. Never tried it. Mm.
Like, what if they say no ChatGPT though?
No. Yeah, they usually say that.
No.
Just don't use ChatGPT, you be good. Mm.
But look, you need it.
Wait, how many fucking? Oh shit.
Yo, ask ChatGPT what your name is.
I'm not doing that.
It knows your name, man.
I want Sheila's account. Gotta think I'm Sheila.
Oh,
Mhm. Oh, Car Zero. Oh, okay, I see. I see. We use Car Zero, not sorted car. Okay. Okay, I think this should run now. Oh, we got another. It's sort car. Actually, we don't use sort car. We go ahead and just use regular car. Try running that right there. Okay, now target distance. Yeah, we meant to use lowercase car and stack pop. Let's see.
what did you use to record it?
Zoom.
Yeah, that's fire.
Okay, now we gotta check while stack. We go ahead and stack pop. No, I say if stack. If stack. If stack. Then we go ahead and stack pop. And we also go ahead and append. Okay. And we got a wrong answer right here. Let's see what's wrong. Hmm. Okay, let's go ahead and check what we did wrong right here. Hmm. From farthest to closest. Hmm. Ah, I see. So we're supposed to actually sort it opposite. So we do sort car, this, and we can say reverse is equal to true. We should not pop. Mm. Target distance. Mhm. We actually reverse this. Ooh, or time. Look at distance. It's not stack.
Yeah, so what's wrong, bro? Can you explain to me what's going on?
For my code, that
Yeah.
shit is I don't know, I can't really think too hard right now. I had it up until I listened to that song and I kind of like I got immersed with the song. I kind of forgot what I was doing.
Oh,
Let's see if
so you want to hear another
no, I was done with discussion. I swear I was done. Since I'm counting my fleets incorrectly. Oh my.
one? Oh,
I,
fleets. Is that like the it's like a bunch of ships?
yeah, except in this fleet it's a bunch of cars. It's just a group of cars that hit the finish line at the same time. That's considered a fleet.
Oh.
You know, maybe I'll just solve this later. Solve this question later, bro. All right, guys, that's the end of the video. I'm gonna go ahead and try to solve this question later. See you guys later.